Okay, angle of elevation and angle of depression today. We're going to do word problems that involve trig. So pay attention to this. This is new. So we have a person here, and we've got a horizontal line with angle of elevation and angle of depression. We always have a horizontal line. So horizontal lines go this way, or they go up and down, left to right or up and down? Left to right. Yep. So here's our horizontal. And so our angle of elevation is going to be looking up. So going up this way. So that's looking up to the plane. This person looking up to the plane would be an angle of elevation. Okay. And then an angle of depression would be, again, this is a horizontal, always with a horizontal line. And we're looking down, depression, down to the dog. Okay. So here's the angle of elevation, and here's the angle of depression. So if I place one on top of the other, what's the name of that shape there? The rectangle. Yeah, it's kind of a little bit hard maybe to see that the sides are not the same length. It's a rectangle. So if we take that rectangle, cut it in half, what are the angles here and here? Right angles. And then this triangle here, this angle, let's see, this angle here is an angle of depression, because we are looking with the horizontal is here and we're looking down. Okay. And then this triangle here, this angle here is an angle of elevation. What do we know about opposite sides of a rectangle? The number of things that we know. What is it? What are the things that we know? So those they're going to be congruent. That's right. Good. Good. Math, geometry word, congruent. Are they parallel? Yes. So since they are parallel, this line here that cuts that rectangle in half is going to be your transversal. And so you're going to have these two angles here, which are what relationship to each other? When you have two parallel lines cut by a transversal. What are those called? They're congruent. That's right. And what are they called? Anybody remember? Are they interior or exterior? Interior. And are they alternate? So they're alternate interior, and alternate interior angles when those two lines are parallel are going to be congruent. So when I put one on top of the other, they're really the same angle. Okay. The reason I'm saying that is that a lot of you are going to go to draw your triangle, and you're going to draw your triangle like this. Okay. Did I put an angle of depression here? No. Okay. So this is never going to be an angle of depression in a triangle. That's a really common mistake. Students want to make that the angle of depression. Okay. Always with the horizontal. Okay. So we're going to solve a word problem. Radio tower, 200 feet high, cast a shadow 75 feet long. What's the angle of elevation of the sun? So here's a radio tower. And it is 200 feet high. And you've got a sun here that's shining over that, and it casts a shadow. Where will the shadow be? I'm going to make a right triangle here with this. Here's my right triangle. What part of that triangle is the shadow? Where would the shadow be? Where are we? So where would it, what part? So this is my angle of elevation here, my theta. What part of that triangle would be the shadow? Where do you see shadows? Mostly you see them on the ground. It's going to be on the ground on this one. So this part of it here, the ground is, this distance is 75 feet. Does that make sense? Okay. The way I drew the triangle, the 75 is longer than 200, but it's not. This is just a sketch. So we want to find our angle of elevation. So here's my horizontal, looking up is my angle of elevation. Does that make sense how I drew that? Okay, because that's going to be the hardest part for you, is drawing it. Okay, so here's my person. What is 75 in relationship to that theta? Adjacent. And what is the 200 in relationship? The opposite. So using TOA, which trig function would have the opposite and adjacent? Tangent. So we are doing tangent of theta in this case is the opposite over the adjacent, which is 200 over 75. So what, how do we find out what that angle of elevation is? That's right, we have to do the inverse. So we're going to do tangent inverse of tan theta. Tangent inverse of 200 over 75. So theta is going to be equal to the tangent inverse of 200 over 75, which is I know how to do it. I want you to do it and tell me. Do that on your calculator. What do you get? Would you? What's that? Yep. And 69.4 what? Degrees. So that's your angle of elevation, 69.4 degrees. That makes sense? Okay, moving on to the next one. Okay, the angle of depression from a ship to a large object on the sea floor is 29 degrees, and the distance between the ship and the object is about 1,400 feet. About how far below the surface of the water is the object. So here's my ship, because I'm such a good artist. It's not my forte, obviously. So here's my object. And about how far below the surface of the water is the object. So the angle of depression from the ship to the object. So my horizontal is here. Here's my horizontal line. So my angle of depression will be here. It's with your horizontal, we're looking down, so that's my angle of depression. Does that make sense? So now the distance between the ship and the object is 1,400. So if I'm finding the distance between where I'm standing and David, okay, would I find the distance from this direction here, or would I go straight from me to him? Yeah, straight from where I am to he is. So that's shortest distance when we say that distance. So what part of this triangle is the distance between the ship and the object? The hypotenuse. So right here is your 1400 feet. Does that make sense? So sometimes that is hard. Sometimes there's a tendency to not make it the hypotenuse. But again, when we're saying distance, it's that shortest distance. Okay, we want to find how far below the surface of the water is the object. So which part of this triangle would be, so let's make this our person, where the boat is. Which side of that would be the distance below the surface? Opposite, that's right. So we want to find this side here. And this is opposite. This is hypotenuse. So what trig function has opposite and hypotenuse? Sine. We're going to find the sine of 29 is the opposite, which is x, over the hypotenuse, which is 1400. So what would we do to solve for that? What do we do to both sides there? Multiply by 1400. And these cancel. And we get 1400 times sine 29 is x. The nearest tenth, that would be so what do we get for that answer there? Yes, 678.7. And what are the units on it? Yep. The units on it are feet. Okay, go ahead and do the last one for a U try. I did it already. 45 string. Okay. Very nice. Yeah, good. So I'm expecting you to work on this on your own right now. Once you're working on the U try, number 3. I'm guessing these are bad. Oh no, what is it doing over there? No, they're over there. This when they get us into rows, that's what happens.
Hey, we do that.
So
35 feet, 40.
no, because this is the kite string that got caught in the tree.
This I know is 34.
Okay.
But
And what you, yep,
this
perfect.
is the longest
Yep.
possible.
Yep. Yep, good. Everything looks good.
I knew you were wrong, bro. Bro, I'm trying to figure this out, man. Oh, okay.
So if you are more specific in your picture, it might help. Like, see how he drew a tree, then he knew that that distance there.
Trees make me happy.
Oh, it says it gets stuck in a tree, which is 34 feet from where you're standing. So this is 34 feet.
Oh, from where I'm standing. I thought it was
Yeah.
34 and higher.
Bless you, Hayden.
So draw a tree and draw the. So I see the person. That's good. Now draw a tree. So where is the tree? Yeah. So before you draw your tree, yeah, So your tree is at the top of the tree is where the kite is located. Yeah. Yeah. So that kite is up at the top, huh? Right up at the top of that corner, that rectangle or that triangle. Yes, it is. Good job. Can we do night? 40.9 degrees. So, yeah, it's cosine. Yeah, good. And so cosine is what over what?
I'm not wearing any braces.
Uh-huh. Good. So I'm going to have somebody pass out the worksheets. If you have questions on this, I'm going to do it up here. But some of you did not. Some of you got it. So I'm going to ask one of you guys to pass it out. So you guys decide amongst each other who's going to pass it out. Okay, so if you could just sit quietly, please, so that those people who have a question on it can hear. So here's a tree. We got a kite stuck in the tree. Let me draw that red. And so we've got 45 feet of string. So once again, if you could just sit quietly, please, for those people who need to listen for when I'm going over it. So my hypotenuse is the 45 feet. And then it says we want the, and it says that it gets stuck in a tree, which is 34 feet away from where you're standing. So here's the person, 34 feet is going to be here. Does that make sense? So my angle of elevation is with my horizontal, which is here. So it's this angle here. So we are finding 34 is what in relationship to that? It is adjacent. The 45 is the hypotenuse. So it's cosine. Okay, once again, please just sit quietly while I'm explaining this. It's just going to be like a minute longer. So adjacent would be 34 over 45, and then we take the cosine inverse. And we get 40.9. Is that what you got? 40.9 degrees.